All right, y'all. So we're back with domain and range of quadratic functions today. So it says Marta graphs the function f of x equals x squared plus 4x plus 2, and she wants to determine the domain and range. So A and B are just asking to label what domain and range are. Well, I don't know if you've heard of those words before, but domain, that deals with our x values. So the domain is going to be all the x values that we can plug into this function. Range is y values. So the range would be right there. So you got range, which goes up and down. Domain is left and right. So the domain of this function is actually, well, I can plug in any number I want as far left or as far right. This graph will keep going up, 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 up to the right. This graph will keep going up, 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 up to the left. So I can plug in any number I want. So my domain is going to be from negative infinity to positive infinity, meaning x has to be less than infinity or greater than negative infinity. So anywhere in between negative infinity and positive infinity. Now the range, though, the range is limited here because of the vertex, and it goes down, but then it comes back up. So we'll never go below this value here, which in this case is the value of negative 2, right? So our range are all y values greater than or equal to negative 2, meaning anything negative 2 or greater is a possible y value. So going off of that, what key feature did I just use to help me figure that out? Well, for the domain, we don't really have a key feature. It's just really always going to be this unless we're talking about a real world situation. But the range is always, where's it at? Range, we always find from the vertex, specifically the y value of the vertex. Okay, so here in this next little part, we're going to kind of do a couple of examples to kind of write the domain and range of these functions. All right, so for this next part, we're going to circle any of the ones that have a domain of all real numbers, meaning that negative infinity to positive infinity I was talking about earlier. Well, A here would have all real numbers because it would keep going left, 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 right, right, right. This one as well. It's a quadratic, so it has a domain of all real numbers. Now look at this one, though. This one looks like it's something that's based on seconds and feet, so height. So this one's a real-world scenario, so it's limited, right? We don't see the quadratic keep going, so it's limited here, so this would not be all real numbers, but D would be. Now, is it possible for a quadratic to have a range of all real numbers? Well, that is no, right? Because it always has a minimum or maximum, right? Meaning it has a lowest point it will go, or it will have a highest point that it'll go, like this one here. Okay, so let's just quickly look at these ones right here. So the domain, again, is going to be all real numbers. So from negative infinity to positive infinity. And the range is going to be y values that are, well, in this case, it's a minimum. So it's got to be y values greater than or equal to this y value here, which looks like it's negative 7. Okay, same thing here. Domain is from negative infinity to positive infinity. And the range in this case, it's y. Well, here we have a maximum, so it's got to be all y values less than or equal to this y value, which looks like it is 3. So all y values less than or equal to 3. Okay, so let's flip it over. Now, kind of what I was just saying, the domain and range of a quadratic function can be determined from a quadratic equation. The domain of a quadratic function in standard form will always be all real numbers. all real numbers. To determine the range, we have to use some different steps though. So first we have to look at the a value to determine whether it has a maximum or minimum. The maximum or minimum of the function is found, or find the maximum or minimum by finding the vertex, and then write the range using the maximum or minimum. Okay, so easy thing for domain, that's negative infinity to positive infinity. And our range is going to be found by finding our vertex. Well, it's a positive a value, so we know it's going to look like that. So our range is going to have to be greater than something because it's got to be from this value up. Well, like we talked about yesterday, we can do the negative b over 2a, right? That's going to be negative 10 over positive 10, which is equal to negative 1. But again, that's the x value of the vertex. We need to find the y value by plugging it back in. So negative 1 squared is 1. 1 times 5 is 5. Negative 1 times 10 is negative 10 plus 8. So 5 minus 10 is negative 5. Negative 5 plus 8 is 3, which means that y has to be greater than 3. Okay? All right, so we're going to take a look at the ones here at the bottom, and then you guys are going to practice this a little bit. Okay, so the domain here is going to still be from negative infinity to positive infinity, just like every quadratic, but the range, we're going to have to find the vertex. So again, let's find our a and our b. So a is negative 1, b is 6. So if we do the negative b over 2a, or opposite of b, which is negative 6, over 2 times our a value, which is negative 1, we will get negative 6 divided by 2 times negative 1, which is also negative 2, which will give us 3. So our x value of our vertex is 3 something. So we're going to take that 3, plug it back in, and we'll see what we get out. So if we use a calculator for that, let's see here, we got negative 3 squared plus 6 times 3 minus 14. Which is negative 5, which means our y value of our vertex is negative 5. So we know our range has something to do with that. We just need to determine, is it going to be less than negative 5 or greater than negative 5? Well, this negative here is telling me it's opening downward, which means we're going to have a maximum. So it's all going to be all y values less than or equal to negative 5. Okay, so we're going to do the same thing for 6 here. Find the a, which is 2. The b, which is negative 12. The opposite of negative 12 is positive 12, divided by 2 times our a, which is 2. So 12 over 4, which is 3 again. So our vertex is 3 comma something. But just like the other domain one, it's going to be from negative infinity to positive infinity, or all real numbers. And our range is going to be, well, y has to be less than or greater than whatever we get when we plug 3 back in. So if we do that, 2 is 3 squared minus 12 times 3 plus 9 is negative 9. So we know this has to be negative 9, and now it's a positive a value, so it's opening upward, which means this is going to be all y values greater than or equal to negative 9. Okay. So the next one we got here is a table one. So we're going to see if we can find the vertex from this table. So here I see it's going up, up, and then down, and then down. So this is my vertex, -2, 13. Which means that our range is going to be something to do with that 13 and y. So if I'm thinking -4, 5, -3, 11, -2, 13, -1, 11, 2, -19. So it looks something like that, right? So here, this looks like it's opening downward. So this would have a maximum, which means y cannot go above 13. So y has to be less than or equal to 13. Now, a quadratic function that has a domain of all real numbers and a range of y greater than or equal to -7. So we're going to find -7, which is right here. Well, if they have to be greater than -7, it has to be all y values up here. So we can just sketch something like that. Now, nothing's below -7. Everything is above -7. All right, and then our last question here is, what is the domain of the function? Well, here we're talking about a Nerf bullet being shot into the air and the height being recorded over time. So in this case, we're not going to have all real numbers because we're talking about a specific interval of time here, right? We can't have negative time and we can't have negative distance, right? Or negative height. So here the domain is going to be from where we start, which is 0 seconds, all the way until we get to the ending spot of 1.5. Now the range looks like we have a maximum here, right? So the maximum means it's got to be everything less than that. Well, what value does it reach? It reaches 9 feet. So y has to be less than or equal to 9. And to answer C, if a bird was flying 10 feet above the ground, could Raul hit the bird? Well, if 10 feet is right here, does that graph ever go up and reach it? Nope. So if there is a bird flying 10 feet, he would not be able to hit the bird because the Nerf bullet only goes up 9 feet. All right, it will never reach 10 feet. The maximum height it can be is 9 feet.